Hi everyone. Here we go with Math 11 assignment number 4, page 189, 4, and 5. So I posted hints for this assignment, and this is the follow-up. So this is the solutions, and you'll also find these posted on our course page. Okay, so we have 2 points, A at 2, -2, and B at 8, 5. I drew those so I could get a sense of what's going on. And somewhere I'm going to have a school placed here such that it is equidistant from A and B. So it could be here. That would be the midpoint between A and B. It could also be along any point along this, what I right now is an imaginary perpendicular bisector. So anywhere along this perpendicular bisector, this new school could be. But they give us a hint. They tell us that the new school would be located at -x plus 7y is equal to -4, which I have over here. And I solve that to be y equals 1/7 x minus 4, 7. Now, it'd be really nice if this new school located along this road also just happened to be this road here, this perpendicular bisector. But it's not, and I know it's not because this is a positive slope, and this perpendicular bisector is a negative slope. Okay, so that's not the case. But we do know, again, somewhere along here, this new school will be located. All right, I'm going to find out the midpoint first, which is just this formula here. I do that, and I get 5 and 3/2. Which is this there. So the midpoint is there. Because what I'm trying to find is what is the equation for this perpendicular bisector. And then once I know the equation for the perpendicular bisector, I'm going to take this, set it equal to this, and then solve for x and y. There we go. And there it is, but how did I get there? Okay, so first thing I did, so I need a slope and I need a point. And so here's my point, that's my midpoint. Now I need to know what the slope of this line is. Well, I know the slope of this line will be the negative reciprocal of this slope. So what is this slope? Well, for this slope, I can just find that here. 5 minus 2, which is here, 5 minus 2, and then 8 minus 2. And so I find out that the slope of this is 7/6, which this one, therefore, must be -6/7. And why -6/7? Because, first of all, that's just 7/6 flipped upside down, and the positive turned into a negative. And second of all, because 7/6 times -6/7 is equal to -1. And that's the case when you have perpendicular bisectors. Okay, so what else? So the next step is continuing along. I have a slope, I have a point, and I can just stuff that into my point slope form of an equation. There's my slope, there's a point, this is the midpoint. I go through that, I go through this, have fractions here. I need a common denominator, add these two fractions together. So I'm going to multiply this by 7 to get 14. I'm going to multiply this by 2 to get 14. Whatever I do to the bottom, I have to do to the top. So multiply by 2, multiply by 2. Likewise, whatever I do to the bottom, I have to do to the top. So I multiply by 7, multiply by 7. That gives me this. And then I simply add these together. That gives me this. And then what I do, part C here, is I add together, I set these two equivalent to one another. And that way, that will tell me what point that they have in common. So I do that, and I get x is equal to this. And this is just combining here. And then now that I have my x value, which comes out to 6.36, I can then take that and substitute it in for y. And in this case, I end up using the road equation that they gave us in the beginning right here. And I substitute x, which is 89/14, into that. And away I go. I get 33/98, which comes down to 0.337. Okay. Question number 5 asks for a triangular park. And of course, I drew a diagram here. A triangular park has these 3 coordinates. And they want to place a fountain somewhere within this park such that it's equidistant from these 3 points. So a few things to know here. First of all, the most important part is that if I find the perpendicular bisector of AB, which just happens to be this, that means that every point along here will be equidistant from A and equidistant from B. So for instance, if this is a distance of, if this point here is a distance of 5 meters from A, then it must be 5 meters from B. If this point here is 3 meters from A, then it must be 3 meters from B. Likewise, my perpendicular bisector of AC is this line, and if I have all points here, any point along here is going to be equidistant from A and C. So what that means then is that the intersection of these two perpendicular bisectors will end up being the point that is equidistant from A, B, and C. And even though I used AC, I could have found the perpendicular bisector of BC and went and matched up these two perpendicular bisectors or these two perpendicular bisectors. It doesn't matter. So if it's equidistant from A and B and it's equidistant from A and C, then that must mean that it's also equidistant from B and C. So again, let's just go back to the example here. If you find out that this point here is equidistant from, if you find out that this point here, because remember, any point along here is equidistant from A and B. Equidistant, 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 equidistant. And every point along this line, including this one, which also happens to be along this line, is also equidistant from AC. And so that means it's going to be equidistant between all three. Okay, so that's a very long explanation of that. Now the meat of it. So the first thing I'm going to do is I'm going to find the equation of the perpendicular bisector of AB. Again, I start off with my point slope form of the equation. So find out the slope of AB. So that's here. I find out the slope is 1. So the slope of the perpendicular bisector then is going to be -1. And again, because this times this must be equal to -1. Okay, so I got that. That's fantastic. Now I need a point. Any point will do, but a midpoint is easy to work with. So then I find the midpoint of AB. That's over here. And so that's 3/2 and 3/2. That was easy. And then what I need to do is find the perpendicular bisector for AC. And so this right here is y equals -x plus 3. This is perpendicular bisector of AB. So this here, I can fill this in now, I suppose. Y equals -x plus 3. Okay. And yeah, so that's step 2. So let's go on here. Now we're going to find the perpendicular bisector for AC, and again, I'm going to use my point slope form, so I need a slope and I need a point. So let's go with the point first. I'm going to find the midpoint of AC. That's 3, -1. Then I'm going to find out what I need a slope because it's a point slope form. So I need a slope. There we go. And we need the slope of the perpendicular bisector of AC, and that is come back here for a moment. This gets a little bit tricky here. Okay, this is all on the same line. This is y equals -1. So any line that's perpendicular to y equals -1 or y equals 2 or y equals 3 or y equals 4 or y equals 1,000,000 for that matter is going to be an x is equal to equation. So in this case, this is x is equal to 3. And if you remember, vertical lines do not have, the slope is undefined. So my equation here is just going to be x is equal to 3. Okay, so going back here, so it's x is equal to 3, which does not have a defined slope. So there we go. So where do the perpendicular bisector of AB, which remember is y equals -x plus 3, that's what we just figured out in the last part, and the perpendicular bisector of AC, which the equation is x is equal to 3, where do they meet? Well, they meet, again, where we set these two equations equal to one another, but that's just going to be where x is equal to 3. And if x is equal to 3, I plug that into here, and then I get y is equal to 0, which makes perfect sense if you look at it. Yeah, that is 3 and 0 if you draw your diagram well. Okay, but let's prove so analytically, which is what we're doing. And that's all I say down here is that they meet at 3, 0.